We are live, ladies and gentlemen. One more question. What do you want to look at? 74? All right, 74. So on number 74, what you've got here is square roots of a whole bunch of junk. So what I'm going to do is rewrite this through as the square root of 9x squared y over the square root of 32z cubed. All right? Now, as you go through this, you're basically taking the square root of each of these individual parts. What is the nth root for a square root? 2. All right, so there's a 2 out here. So if you want to think of it that way. What's the square root of 9? Square root of x squared. X. And then now I cannot simplify the y value, so it's still square root y. Okay? You can, but what we talked about yesterday is that by leaving in the roots, it's a little bit cleaner than using the exponents when you get into some of these, okay? Now, in the denominator, square root of 38. What's the largest perfect square that goes into 38? Or 32, I should say. 16. So that's 4 root 2. 2 goes into 3 how many times? 1. So how many are left over? 1. So you take 1z out, and you leave 1 in. You agree on that? Square root of 32 is 4 root 2. All right. Now, do you like radicals in your denominator? No. So what's the quickest way to... Now, in this case, rationalizing should be simple because we've done this method before with square roots. What do you have to multiply the top and the bottom by? Square root of 2z. So when you do that, you wind up in the numerator with 3x root 2yz over square root of 2 times square root of 2 is 2. Square root of z times square root of z is z. So you wind up with 2 times 4, z squared. Okay? Remember, square root of junk times square root of junk is junk. 66. Ooh, that's scary. Oh, that's 67. Okay. Now, in this case here, if you look at your numerator, you have the identical nth roots. Do you agree? So that means I can combine them. Square root of x, the square root of x cubed becomes the square root of x to the 4th. So I'm just going to rewrite it right now as 2x root x to the 4th. Okay? And then down here, you could probably simplify it real quick. Because remember, the nth root here is a 2. So the square root of 9 is 3. 2 goes into 10 how many times? 5. So it's x to the 5th. All that's left is to simplify the numerator. That's the square root of x to the 4th. X squared. Excellent. So it's 2x squared over 3x to the 5th. And last but not least, yeah. So 2 over 3x to the 3rd. Remember, because the 5th power is bigger. That's where it says. Yeah, it works the same way. It'll work the exact same way. It's just since they're all square roots, it's just sometimes quicker to go that route. You should get the same result. Okay? I'll walk you through it. Go. It's really nice because once you have whatever the nth root is when you're going into the exponents, it's just quick division. 2 goes into 10 how many times? 5. There's nothing left over, so you don't have to leave anything under it. If it was 11, you'd leave 1 underneath the radical. That's all. That's it. What else? 60? All right? Do these guys have the same base? Guys, they have the same base. All right? Since they have different exponents, which one is larger, 3/7 or 1/3? 3/7? So all you have to do is subtract 3/7 minus 1/3, and that gives you your new exponent. That's the same thing as x, so 9/21, 7/21. So it's x to the 2/21, I believe. SMRT. What else? Were the exponents and variables easier than numbers?
I like
72.
Which one? 72, last one. Oops, sorry, cut that one off. Okay. In that denominator, you've got a cube root. So what you want to be able to do to eliminate that denominator, you want to turn it into a perfect cube. Right now, your exponent is just 1. What is the next multiple of 3 that comes after 1? 3. Okay? So what do you have to multiply this x by to turn it into a multiple of 3? X squared, thank you. So you have to multiply top and bottom by the cube root of x squared. Oops, sorry, it's x squared. So your final answer, this becomes the cube root of x cubed. And then the numerator is 4 cube root of x squared. And you're done. Remember, you want to create that perfect cube root or the perfect nth root, whatever it winds up being in the denominator. The stuff we're doing today is actually much easier. Okay? There's a little combination of stuff. I think today works out well at being just a little bit shorter. What happens here when you multiply these in, you wind up with the cube root of x cubed, and that gives you x. What you're trying to do is create a perfect cube, and that's how you eliminate that radical. Okay? If it was x to the 5th, I'd multiply this one by x to the 4th, top and bottom, to create a 5th. You know what I mean? That's what we're doing. All right? Make sure your name's are on them.